Hello, everyone. My name is Kevin Lance, and I am the Analytics Marketing Manager at Unchained Labs. Today, I'll be your moderator, and so I want to thank you for joining us. We will have a Q&A session at the end of the presentation. So to ask questions, all you have to do is click on the Q&A button in the Zoom navigation bar at the top or bottom of your screen and type in your question. We'll get to as many of them as we can. And now, I'd like to introduce Nellis Dennis, the Product Manager for Stunner at Unchained Labs. Today, Nellis will walk us through how you can make confident and quick decisions on your AAV samples with Stunner's dye-free, label-free, standard-free, and hassle-free AAV quant. And now I'll hand it over to Nellis.
Thank you for that introduction, Kevin. Now let's get right to it with my talk, Tighten Up Your Titers with AAV Characterization on Stunner. In this famous painting, ceci n'est pas une pipe means this is not a pipe. And it's the artist's way of saying that you might think you know what you're looking at, but that may be incorrect. This is not actually a pipe, it is a painting of a pipe. Similarly, knowing what you have for AAVs can be a major challenge. You might think you've got a perfectly happy, non-aggregated full AAV sample, but that may not be the case. That is where Unchained Labs wants to help out with our gene therapy squad. Today we will focus on Stunner, but when you're interested in how to automate your time-consuming buffer exchange, cleanup, and concentrating steps, please check out Big Tuna. Or when it's time to pressure test the stability of your capsids, Uncle gives new insights on AAV stability by monitoring DNA ejection from capsids, in addition to protein unfolding and aggregation. Never hesitate to reach out to us for more information on these systems. Now, when characterizing AAV, you have a lot of things going on. It's important to know how much protein is present, how much DNA is present, if things are intact, if they're the right size, and if there's any aggregation. It's a truly complex biologic that demands a lot from characterization techniques. That is why characterization of AAV is a very broad subject, and it's still evolving. For every one of these needs, there are many technologies trying to meet the need. Today, I'll show you how Stunner can help address the needs shown in green. So that's titers for full capsids and total capsids, an empty full ratio, and if there's aggregation going on in your AAV sample. Now let's focus in on two technologies, DLS and UVS. Each of them tells a part of the story. DLS gets you info on capsid titer and aggregation, but can't say anything about what's happening with DNA. On the other hand, UVS gets you total amounts of protein, DNA, and can link those to empty full ratio, but doesn't give you info about if any of this is contained in capsids. Each gets valuable info, but neither tells you everything. So what if you could combine them to get a whole story? That is where Stunner brings it all together, to deliver answers on capsid titer, empty full ratio, and aggregation with only 2 microliter of sample in less than a minute. And there's no labels, no reagents, no standards whatsoever. You just use the sample you've got. Now, how does Stunner does all this? Simply add in 2 microliter of AAV above a titer of 10 to the 12th into the input well, and it's pulled into the microfluidic reservoir. At this step, the sample can sit for up to 2 hours before reading with no evaporation. After the plate is loaded into the instrument, the circuit is read first when empty, and that will remove any absorbance contribution from the plastic. Then a pump applies a small vacuum which moves the sample into the microcuvettes to be read. Because the circuit has fixed pad lengths, it can make very precise and accurate reads. Stunner contains 2 technologies to read each sample, the UVS for concentration and DLS for sizing. SLS intensity data is also read during a DLS experiment. And samples can be read from 1 to 96 samples at a time. Stunner's AAV quant application will combine all the pieces of information into the full story about your AAV. Checking out your AAV with DLS tells you what shape your sample is in, if there's only capsids or if aggregates have started to ruin things. DLS also lets you figure out how much SLS intensity is coming from just your AAV capsids. That's the green peak on the bottom left, while the gray peak is the aggregates and larger stuff. UVVis brings information on how much total protein, how much single-stranded DNA there is, and based on some simple info you tell Stenner before an experiment, it will calculate your empty full ratio and your percent full. Now, how exactly it works is shown step by step here again. First, DLS identifies the capsids, the aggregates, and how intense the signal is from each of those populations. In the middle, the info then helps you split up your SLS signal from a total into the amount just attributable to empty and full capsids combined. And finally, UVVis brings in that info about empty and full ratio, plus the totals for protein and DNA to provide the last piece of the puzzle. And here's that whole story told in one graph, starting with the left side blue bar, which is the protein in a sample. UVVis got you the total amount of protein, and here we're expressing it as how many possible capsid all that protein could make. By adding in DLS and SLS info, Stenner splits up that big blue bar and splits it into the light blue bar, which is the aggregates and extra protein junk, and the dark blue bar, which is the total titer for your AAV capsids. On the right-hand side, you see a green bar. The process follows the same steps for DNA. So the total height of the green bar is the total amount of DNA, expressed as the total number of viral genomes that you can make. Light green is extra DNA, and dark green is the number of full AAV capsids. Dividing the dark green, so the full capsids, by the dark blue, the total capsids, gets you to a percent full number that we also convert into empty full ratio for you. Now here's that same data showing how Stenner helps you know your AAV inside out. Dark green divided by dark blue is percent full, which is shown in yellow, and purple is percent empty, which is just the remainder. Empty full ratio is percent empty divided by percent full, and so purple divided by yellow. If your preferred term is CP per VG ratio, that will be just the inverse of our percent full number. Now plotted here are the percent CVs of various samples from different serotypes ran at different concentrations. Each sample was run in octuplicates, and we are reporting the total capsid titer. As you can see, Stenner does it all with amazing precision. Over all these samples, the percent coefficient of variation on total capsid titer was below 15% CV. To look more into our ability to see percent full values, we took stocks of empty and full AAV9 and then mixed them at different ratios. For each combination, so 100% full stock, 80% full stock, and so on, Stenner gets a good read on the data, and percent full and percent empty align perfectly with the expected values. And this application works for any serotype. Just tell Stenner the basics about what serotype you have and what its DNA payload is, and Stenner takes care of the rest of the heavy calculating. For getting capsid titers, Stenner is way faster and requires less upfront work than ELISA's. Here we've taken full or empty AAV9 and ran a dilution series where we've compared Stenner's total capsid titer metric against the results for a capsid ELISA. The results have slopes close to 1 and R-squared values above 0.99. And importantly, it would take hours to get this ELISA data, while Stenner's done it in less than an hour with no sample prep. Now, assessing AAV storage conditions is a slow process, made even slower when the only analytical tools you have are functional assays. Storage experiments are made more complicated because some AAV stereotypes are more prone to aggregation than others. Functional assays might tell you that you have lost infectious particles, but won't tell you why. Stenner's DLS shows if a sample has aggregated, so you can tell when a sample of AAV has gone bad without wasting time on cell-based assays. Standard DLS intensity distributions of AAV2 and AAV9 are shown here. Both were stored at 4 degrees for 2 weeks. Now, AAV2 showed peaks at a much larger hydrodynamic diameter than AAV9, indicating significant aggregation. The large light blue bar of the AAV2 sample shows the extent of storage-induced aggregation, while the dark blue and green bars dominating the graph for AAV9 show that most of the sample is intact, full capsids. Quickly rejecting samples you know won't work in a cell-based assay saves time and means you can focus on the samples you know will work. Next to that, choosing the right buffer in formulation studies of AAV vectors is absolutely necessary, especially when it comes to pH. If the tools you use to characterize your AAV are too slow or take too much sample, you might miss out on the optimal buffer. What is shown here is we heated full AAV9 to 45 degrees for 25 minutes in a neutral buffer, pH 7, and that caused some aggregation. But heating the same sample in an acidic buffer, pH 4, caused nearly complete aggregation. With its lightning fast DLS reads, Stunner makes it easy to evaluate more buffers and stress conditions than traditional methods while also providing tighter results. And if Iodicional is part of your process, it is useful to know exactly how much is in your sample and to check on the Iodicional concentration after each buffer exchange. Stunner can also help you out here and will detect Iodicional in your sample as low as 0.0005% by volume. So from only 2 microliter, Stunner combines UVS, DLS, and SLS data to tell the whole story about your AAV, delivering mountains of data about sample aggregation, AAV full and empty capsid titer, and empty-full ratio. That is how Stunner delivers label-free, standard-free, and hassle-free gene therapy quant. Now, in this trending painting, ceci n'est pas aggregé means this is not aggregated. With Stunner, you will know what you are looking at and get the needed details. Make confident and quick decisions on your AAV samples with Stunner. And I'll take any questions now.
All right, thanks, Nellis, for that quick overview of Stunner's AAV quant. So what we saw, today was the value of the combination of both UVS and DLS technologies, how we can understand size and size distribution, as well as the actual components of DNA and protein present in the sample at the same time. And especially on Stunner, doing that in a high throughput and small volume way. It's very practical for AAV. From that combination technologies, we're looking at everything from capsid titer to genome titer, and then things that are not packaged in AAVs as well. And then a couple examples of where that can be used, looking at capsid titer very quickly with that precision graph, as well as looking at sample QC for different lots, looking at aggregation over time, and then aggregation as a result of changes in pH. So pretty nice little assay and a couple different application spaces that can be used. And we do have some questions that are coming in. So I will start asking those. And then if you have more, please go ahead and type them into the Q&A question button, and we'll get to as many as we can. So first question. So if I scan multiple serotypes to find the best one for my gene of interest, can I measure them all on the same plate?
Yes. You can actually. Stunner makes it very easy to make different sample groups, so you can specify different serotypes. The main thing if you want blank, you'll need to blank for each serotype that you want to put in a sample group, but there's no problem on running multiple on one plate.
Okay. And then another question is, how can you tell, based on the data that Stunner is outputting, how can you tell if the DNA is inside of capsids or outside of capsids? Essentially looking at, how do you tell where there's dark green bar and light green bar for your capsids?
So that's mainly the strength of combining these two technologies. Our UVS will measure the total amount of protein and the DNA. And then with the DLS and SLS, you'll get an indication on what the total particle count could be for empty or full capsids. And combining those the difference will be what's in and outside the capsids, because the DLS and SLS will show you nice monodispersed capsids. And by combining that, we'll divide those both total amounts, and the difference is basically the leftover.
Okay, yeah. So that makes sense. If you're kind of looking at what's the maximum by 2 different detection technologies, then when you start comparing and contrasting those, you can answer some pretty interesting questions. Okay, another quick question. What sample prep do I need to do?
That's a very quick question because there's basically none. You just need 2 microliters and you pipette it in your plate, and that's all you need to do, and put it in the instrument.
Okay. So we were talking about AAVs. It's the AAV quant application. But can this instrument be used for other viral capsids? What kind of results would you expect? And then what kind of titers can it be used for?
To go specific on titers will vary depending on the vector, I would say. This application itself is very much specified for AAVs, but of course, Stunner has other applications that do UVS and DLS combined, so there's no problem on getting size info, aggregation info on other viral vectors as well, while also getting your UVS spectrum.
Yeah, it makes a lot of sense. You get a little bit, just more of that pure UVS and DLS information. Yeah. Cool. All right. So this question, this customer says, I'm working with a custom AAV, not a natural occurring default serotype. Will that still work on Stunner?
Yes, it will. So what we've done is we predefined the default serotypes there, but Stunner has the full capability of implementing and entering your own serotype, specifying your amino acid sequences and all that stuff. So you can tell the instrument what exactly it is, and Stunner will do all the rest. So no problem if you have your full custom-made sample.
Cool. And can Stunner's AAV quant application, can it tell the difference between partial and full packaged genomes?
No, unfortunately, we can't see a difference there. So it's an empty or full type of question. Really knowing if it's partial in there is not a functionality of Stunner.
Okay. So it could be a good orthogonal kind of complementary technique to other techniques that answer that question specifically, but maybe take longer or require more sample. Yeah,
or are a lot more expensive.
Oh, yeah, true. Thinking about AUC and things like that. Yeah, absolutely. Is Stunner compatible with a LIMS system?
Yes, our Stunner system will generate multiple reports, and you can also specify how your report would look like, the columns you want to output, and you can make reports in multiple file types. So whatever your LIMS system wants, like XML or CSV or any of that, no problem. So.
Okay, cool. And yeah, the questions keep coming, so let's keep going. So does Stunner's AAV quant application work with unpurified AAV samples? So maybe even broader, you could just speak to what kind of sample requirements are there?
So for the perfect read, I would say it's mainly used at the end, at the downstream of your AAV process. So it would be a pretty pure sample overall. So minimum 10 to the 12th VG per ml. And we can see iodixanol, but the moment when you have an extreme amount of iodixanol in there, the UVS absorbance is overflown. So you'll know how much iodixanol is there, but you'll not get most out of your system. It can help you when you want to purify out that iodixanol. That's where you can easily use it there as well. For general unpurified samples, you can always use it as a quick check, but to get the best and most accurate results, we need to have a more purified sample at the end of your process. But you can always use it to do a quick check before any other technique, of course.
Right, makes sense, especially if you're looking at that downstream part of the process and you're dealing with concentrations above 10 to the 12th, then you probably are dealing with pretty purified samples to get to that concentration. Okay, does this system have 21 CFR Part 11 software?
Yes, there's a perfectly add-on compliant license that you help your system completely 21 CFR compliant. So that's no problem at all.
Great. And then we talk about why this application, what's the advantage of doing this application rather than just doing DLS and UVS separately?
So that goes a bit in the, also what I said in the beginning. So with either technique, you only see a part of the story, of course. But on additional to that, with general UVS, not with our systems, you will also need to find a way to distinguish between DNA and protein to get a decent readout of that, to have some knowledge there. And not every UVS system would be able to do so. On a DLS part, it would be pretty much the same, but most systems will require more volume and will be slower overall. And then you have the additional part that you need to still do the combination yourself. You would need to do a lot of calculations on how that's happening, which analyte, which serotype you have, and things like that. And you'll do it on two separate systems. So it will take longer, will require more volume, and just putting it together will make your accuracy go a lot worse overall. So it would be a very difficult job to do it with two separate systems and bring it together, I would say.
Yeah, especially with the accuracy and precision that Stunner delivers. I can see that once you start building in different accuracy and precisions from different instruments, it starts to be a big problem. Okay, so what is the resolution of looking at empty full? What can Stunner distinguish between different empty full samples?
So the example I showed was with a 20% step, and I think I don't exactly know a number by heart, but it's definitely better than that. If we would go back, the error bars on that are around 5%, I would say. So our best estimate would be an average on 10% would definitely be possible.
Yeah, I'm also definitely thinking about that one precision slide too, where if you have a more concentrated sample with a clear, precise signal, then you have better resolution.
That's definitely true.
Statistics. Cool. So let's see. So regarding genome titer determination on Stunner, does it need to factor in genome size?
Yes. So basically you tell the instrument which serotype it is, or you specify your custom serotype, but then you also tell the system your DNA insert size, which is needed to do further calculations on concentration and stuff like that. So you can either specify, if all your samples are the same size, you can just specify it once and go from there, or you can import a template with all your different sizes easily from Excel. So you don't need to manually input it one by one in the software itself.
So, great. So
yeah, so we take it in account, and you need to you need to enter it, but that's it. The software will do all the rest of the calculations.
Okay. And then actually, this is an interesting one. Can you compare and contrast it with the information that you get with ddPCR when it comes to genome titer?
I can definitely compare, but the main difference there is that ddPCR gets you identity, while we get you total DNA titer. So it's practically a different answer, and so you would need to compare. If you really want to do in-house, you would need to keep on comparing the same sample. So you can't just take a number and say it's twice or different from ddPCR. It will be different because we're just measuring the total DNA compared to ddPCR, that's identity.
Yeah, so I think like you said at the end summarizes it well. Stunner is going to be a total DNA answer, and ddPCR will be very specific to identity. Makes sense. And then let's see, can it be integrated with a liquid handling robot?
Yes, definitely. Both our Lunatic and Stunner system have an API software. And so with any robot, you can specify a driver and it will do all the work for you, from loading your plate that's fully compatible to telling the system which application you want and all of that, putting out your plate layout and everything like that. So definitely possible.
Okay, all right. So I think, we had really great answers to all those questions, Nels. So thank you for that, and thank you for the great presentation. I also want to thank all of you who joined us live today. If you would like to have a deeper conversation with our team, please do get in touch with us at info@unchainedlabs.com, or you can visit our website at www.unchainedlabs.com. So we would love to connect with you and have more conversations. And if you had a question in the Q&A, I know we've been having a Q&A for a little bit now, we'll definitely reach out to you and have a deeper conversation about those questions too. So thank you again for attending our virtual seminar, and I hope you have a great rest of your day.